All right, folks. Welcome back. Hope you all had a good Christmas break. And you're ready to finish off these last couple of weeks that we have together. Please keep in mind that since we are about 2 weeks away from the end of the semester, that if you are missing assignments, we need to get those squared away. Please check the student portal to see what you're missing and what still needs to be turned in, and let me know if you have any questions. As we wind up the semester, there is one more chapter that is pretty important for us to talk about, so we are going to spend some time with that. So today we are going to talk about quadratic functions. So we're going to learn what a quadratic function is, and today we're going to focus specifically on how to graph a quadratic function. Next week we will be working on how to solve quadratic equations using a couple of different methods. All right, so first of all, let's talk about what a quadratic function is. And I'm going to show you now the standard form for a quadratic function. Every function that is quadratic will either look exactly like this standard form, or you will be able to make it look like the standard form. All right, so here it is. The standard form is y equals ax squared plus bx plus c. So any function that is quadratic will either fit that form, or you will be able to make it fit that form. Now, I want to emphasize to you here that when we look at this thing, the a, the b, and the c are going to be numbers. So those are going to be your numerical coefficients. So something to keep in mind there. All right, so just to show you a few examples, if I had y equals 2x squared plus x minus 5, that would be quadratic. The a would be this 2, the b would be a 1, because we know there's an invisible 1 in front of that x, and the c would be negative 5. So 2, 1, and negative 5 would be the values for a, b, and c, respectively. If I did something like y equals x squared plus 7x, that would be a quadratic equation. Here is my ax squared term. The a would be a 1. Here is my bx term. The b would be a positive 7. And then notice that c is missing. What that means is that c is 0. I could put a plus 0 there. X squared plus 7x plus 0 would be the same thing as x squared plus 7x. So it's okay for terms to be missing. And if those terms are missing, it just means that coefficient is a 0. So with that in mind, if I gave you y equals x squared minus 25, that would also be quadratic. Notice this time, here is my ax squared term. So my a would be a 1. I'm missing the bx term, so that means the b would be a 0 in this problem, and then the c would be that negative 25 that we see out on the end. So every quadratic function has to look like y equals ax squared plus bx plus c. And it's okay for terms to be missing. If terms are missing, that just means that that coefficient of that term was a 0. All right, now, like I said, we are going to spend time graphing these for the next couple of days. And here's what you need to know. And you'll see this more when we do this in a moment. But the graph of a quadratic function will be a U-shaped curve called a parabola. So the graph for any of these quadratic functions will look the same. It will be a U-shaped curve, and you call that U-shaped curve a parabola. Now, these U-shaped curves can look one of two ways. So here is one way they can look. So you'll notice this U is right side up, or the other alternative is that U-shaped curve can face downward, like this. So the two shapes that I have drawn on the board right now, the two U-shapes, are the two different ways that parabolas can look when we graph them. Now, here's what I want you to notice. On this U-shaped curve that you see here on the left, what I want you to notice is there is a turning point. This U starts out going down, and then we reach this turning point right here, and then he turns and starts to head back up when we draw that U. So this point right here is your turning point in that parabola. And I want you to notice that it's in the middle of the curve. So it's kind of the middle point on that curve. That turning point is called the vertex of the parabola. Now, when I go to this curve over on the right, you'll notice when I drew it, I started out going uphill, and then I reached this turning point right here where I turned and started to come back down. So right here would be the vertex for this parabola. And again, I want to point out that that vertex, or that turning point, is kind of the middle point on that curve, so it's significant. What you'll notice is that half of the parabola falls to the left of that point, and then the other half of the parabola falls to the right of that point. Same thing over here. Half of the parabola is to the left of that point, and then half is to the right. So, to make sure we've got this before I show you how to graph these, your quadratic functions are all going to look like this. Y equals ax squared plus bx plus c. And remember, terms can be missing. There's no problem if they are. And then the graphs of these quadratic functions are going to be U-shaped curves called parabolas that either open up or open down. But that lowest point or highest point that's kind of in the middle of that curve is the vertex. And it is a significant point for any of these quadratic functions. All right, so now I want to show you how to graph some of these, okay? So we are going to begin with this function. Y equals 3x squared plus 6x minus 1. All right, so here's what I want you to notice. Here is my ax squared term. Here is my bx term, and here is c. So if I wanted to, I could go ahead and do this and say, okay, I know that a is 3, because it's 3x squared. I know that b is 6, because I see that plus 6x. And I know that my c is a negative 1. So these are the three numbers that are at work in my equation. Now, when you graph these, we are going to graph these by making a table. And I'm going to ask you, when you graph these, to find a total of 5 points. So there's 1, 2, 3, 4, and then here will be my 5th one. Now, let me kind of number here for just a moment. All right, now here's what I want you to notice. You have these 5 points. This one would be the middle point, the third one. So this third point is where we are going to place our vertex, because remember what I said about the vertex a moment ago. The vertex is the point that is kind of in the middle of that curve. Okay, now there is a formula you're going to have to know. And this formula that I'm about to show you finds the x-coordinate of the vertex. So this formula that I'm about to show you will find the x-coordinate of the vertex. That formula is this. X is equal to the opposite of B over 2 times A. So that is the formula you will use always to find the x-coordinate of the vertex. And remember, that vertex is that turning point. It's that middle point on that U. All right, so what we're going to do is take the values that we have up here from our quadratic equation. We need B, which we know is 6, and we need A, which we know is 3, and we're going to plug them into this formula. So notice, this says to do the opposite of B. So the opposite of positive 6 would be negative 6. And then we're going to put that over 2 times A, so that's going to be 2 times 3. So we end up with negative 6 over 2 times 3. Now, if I do 2 times 3, I know that's 6. So I get negative 6 over positive 6. And when I divide that out, I get negative 1. Now, let's make sure we understand what that negative 1 is. That negative 1 is the x-coordinate of the vertex, of that middle point. So I want you to go right here in your table to this middle slot, and that's where I want you to put that negative 1. Now, you get to choose. You're going to get to pick these other x values. So I want you to pick 2 x values that are smaller than negative 1, and then 2 x values that are larger than negative 1. So in other words, 2 that are to the left and 2 that are to the right. So let's see, going smaller than negative 1, I could use negative 2 and negative 3. And then going larger than negative 1, I could use 0 and 1. So let's make sure we understand how we just filled in the x-coordinates for this table. This one, the middle one, we got by using this formula over here. And then I chose 2 that were smaller than that negative 1 and 2 that were larger. So that first x value I find using my formula, and then the others I get to pick. All right, so now we have x values in our table. We need y values. So how are we going to get those? Well, to get those y values, what we're going to do is remember that we've got this equation up here. And I want you to notice how this equation starts out. This equation starts out by saying y equals. So here is what y is equal to. 3 times x squared plus 6 times x minus 1. So here's what we're going to do. To figure out the y values that go in this table, we're going to take these x's that we have now and plug them into this equation. So first we're going to take negative 3 and plug it in for these x's. So that'll give us y equals 3 times negative 3 squared plus 6 times negative 3 minus 1. Now, you all know that first we would need to follow the order of operations here. So we would do this exponent first. Negative 3 squared is 9, so I would have 3 times 9 plus 6 times negative 3 minus 1. All right, next up I can go through and do my multiplication. So 3 times 9 I know is 27, plus 6 times negative 3 is negative 18, and then I have minus 1. And then last, I can do all of my adding and subtracting. So 27 plus a negative 18 would be 9. And then 9 minus 1, of course, would be 8. So when I plug in negative 3 for x, I get that the y is 8. Okay, so now I'm going to erase this because I don't have a lot of room up here. My board's getting kind of crowded. And we're going to do the second part of this. So now we're going to plug in negative 2 for all of the x's. So that'll give us y equals 3 times negative 2 squared plus 6 times negative 2 minus 1. All right, so first up we'll do our exponent. Negative 2 squared is 4. So that gives us 3 times 4 plus 6 times negative 2 minus 1. We will multiply next. 3 times 4 we know is 12, plus 6 times negative 2 is a negative 12, minus 1. Add and subtract. 12 plus negative 12 is 0. And then 0 minus 1 is negative 1. So for negative 2, we get negative 1 as our y value. All right. Clean us up a space here again. All right, so now we're at negative 1. So we're going to plug in negative 1 for the x's. 3 times negative 1 squared plus 6 times negative 1 minus 1. Do your exponent first. Negative 1 squared is positive 1. So this is going to be 3 times 1 plus 6 times negative 1 minus 1. Now do your multiplication. So we'll do 3 times 1 is 3, plus 6 times negative 1 is negative 6. And now we'll do our adding and subtracting. So the 3 plus the negative 6 gets us a negative 3, and then a negative 3 minus 1 is a negative 4. All right. So notice the process that you're going through right now is not difficult. It's just plugging in and working it out. It is tedious. It is a lot of work to do, but thankfully not difficult work to do. All right, so now let's plug in 0 for x. So we get y equals 3 times 0 squared plus 6 times 0 minus 1. All right, exponent first. 0 squared is 0, so this is going to be 3 times 0 plus 6 times 0 minus 1. Now, let's do our multiplications. 3 times 0 is 0, plus 6 times 0 is 0, minus 1. And then 0 plus 0, of course, is 0, minus 1 would be a negative 1. So we get a negative 1 for our y value. And that leaves us with one more to do. We have to plug in 1 for the x's and come up with our last y value. And then we'll be ready to graph. So we're going to plug in 1 for the x's. So y equals 3 times 1 squared plus 6 times 1 minus 1. We're going to take care of the exponent first. 1 squared is 1. So 3 times 1 plus 6 times 1 minus 1. All right, multiplications. 3 times 1 is 3, plus 6 times 1 is 6, minus 1. Add and subtract. 3 plus 6 is 9, so I have 9 minus 1, and that gives me y equal to 8. Now, I want to point out something here that's going on in our table. We said that this middle point would be our vertex. What I want you to notice is the y values directly on either side of that have turned out to be the same. So both of these have negative 1 as the y value, and both of these have positive 8 as the y value. Now that could save you some work. I think you can see there that that could save you some work, because you could just plug in those first 3 and then use your answers to help you fill in those last 2. So in other words, I could plug in negative 3 and get 8. I could plug in negative 2 and get negative 1. I could plug in negative 1 and get negative 4, and then just say, okay, this one has to be the same as this one, and this one has to be the same as this one. But I do need to caution you about why that happened. Look at my x values. I have negative 3, negative 2, negative 1, 0, and 1. These are consecutive numbers. I didn't skip around. So as long as you have x values that are consecutive like that, then you'll get this matching up of the answers. So we'll talk more about that as we do another example. All right, so now that the table is complete, we can actually graph this thing. So pull up a coordinate plane, a grid. So x-axis, y-axis, and now let's start to plot these points. So our first point is -3, +8. So on the x-axis, we'll go to the left 1, 2, 3. On the y-axis, we'll go up 1, 2, 3, 4, 5, 6, 7, 8. So there's -3, 8. -2, -1, we'll go to the left 2 on the x-axis and then down 1 on the y-axis. Here comes our vertex, -1, -4. We go to the left 1 on the x-axis and then down 1, 2, 3, 4 on our y-axis. 0, -1. We're at 0 on the x and then we'll go down 1 on the y. So notice how those 2 points are mirror images of each other. And then 1, 8, we'll go to the right 1 and up 1, 2, 3, 4, 5, 6, 7, 8. And this U is going to be really skinny. But here's what, whoops, missed a little bit there. Here's what he will look like. So it should be symmetric, and that vertex point right there should be kind of in the middle. And then these 2 right here, and then these 2 right here should be mirror images of one another. So to kind of recap, we had our quadratic function. We knew the a, the b, and the c. We used the formula x equals the opposite of b over 2 times a to figure out the x-coordinate of the vertex. That was our -1. And we put that in the middle of the table. And then we picked the 2 numbers directly below that and the 2 numbers directly above that -1. And then it was just a matter of plugging in. Okay. Let's try another one. Let's try one more. Okay, so for our second one, let's do y equals a -x² plus 2x. So I want you to notice in this quadratic equation, here is my ax² term. And notice in front of it, there is a -1. So in this problem, a is a -1. And then I have my plus bx term. And my b would be that +2. And then notice that the plus c term out here on the end is missing, so that means that that c is a 0. So this is a quadratic function with a equal to -1, b equal to 2, and c equal to 0. All right, so I'm going to get myself ready here. So we want 5 points in our table. This one is going to be the vertex. We are going to start by figuring out what x is for that vertex. And we're going to do that with our formula, the opposite of b over 2 times a. So notice, b is 2. So the opposite of b would be a -2. And then that's going to be over 2 times a, which would be 2 times a -1. First, we'll do 2 times -1 on the bottom and get -2. And then -2 divided by -2 would be 1. So the x-coordinate for my vertex is going to be a +1, which I will place right there in the middle. Now remember, keep your x values consecutive. That will help save you some mark. So I need 2 that are below. So I'm going to go 1, 0, -1. And then 2 above, so I'm going to start at 1 and go 2, 3. So notice I have -1, 0, 1, 2, 3. Those numbers are all consecutive. I haven't skipped any. So that's going to help me save a little work when I fill this in a moment. All right, so let's start with that first x value. Our first x value is -1, which we're going to plug in up here. Now be careful with this negative sign, because remember that means -1 times x² plus 2 times x. So this is going to be -1 times -1 squared plus 2 times a -1. Now let's work that out. We'll do the exponent first. So -1 squared is +1. So this is going to be -1 times 1 plus 2 times a -1. Now we'll do our multiplying. -1 times 1 is -1 plus 2 times negative 1 is negative 2. And then when we add negative 1 plus negative 2, we get negative 3 as our y value. All right, so next up, we are using 0 for x. So we're going to get y equals negative 1 times 0 squared plus 2 times 0. Exponent first, so 0 squared is 0. So we have negative 1 times 0 plus 2 times 0. Now we multiply. Negative 1 times 0 is 0, plus 2 times 0 is 0. So we get y equals 0. All right, 2 down. Now we're putting 1 in for x, so we're going to get y equals a negative 1 times 1 squared plus 2 times 1. Exponent first, 1 squared is 1, so negative 1 times 1 plus 2 times 1. Now we multiply. Negative 1 times 1 is negative 1, plus 2 times 1 is 2. And when we add negative 1 plus 2, we get 1. Now, what we should be able to do here now that we've figured out those first 3 points is we should be able just to repeat our our y values on these other two. So the 0 should go here, and then the negative 3 should go down here. But just to be on the safe side, I'm going to show you that that will work. So I'm going to plug in the 2. So it's negative 1 times 2 squared plus 2 times 2. You'll do your exponent first. So this is going to become negative 1 times 4 plus 2 times 2. And we get y equals negative 4 plus 4, which is, notice, 0. And you could plug in that 3 just to confirm, but I'm not going to do that. So remember, if you choose x values that are consecutive like I have, and you don't skip any, then you really only have to plug in those first 3 numbers. And then the last 2 you can just repeat. So notice it goes negative 3 to 0 to 1 to 0 to negative 3. So that 0 is the turning point, and then it goes back through those values again. All right, so now that you have your table all filled in, let's use a different grid this time. We'll plot these. So negative 1, negative 3 will go to the left 1 and down 3. 0, 0 is, of course, the origin. 1, 1 is right 1, up 1. And 2, 0 is right 2, stay put. 3, negative 3 is right 3, down 3. And notice this time we're going to get that U shape that opens downward. So just to recap again, use this formula to find the x-coordinate of your vertex. That goes in the middle slot. Pick 2 numbers smaller, 2 numbers larger. Make them consecutive. Don't skip numbers, and that'll help you, because then you can fill in these first 3 and get these 3 x values, and then just repeat for these 2. Use your symmetry to help you kind of figure that out. And when you plot the points, you should get a nice pretty U shape that either opens up or down. If you have any questions about graphing, please let me know. You will be doing assignments where you are graphing today and tomorrow. So any questions at all, please make me aware of those. Continue to work on makeup work. Those of you that owe me makeup work would just be my last reminder.